Hi, good day, and welcome back to the Division of Education, Innovation and Energy's e-learning program. I am Mr. Atwell, and today we're continuing with consumer arithmetic. Now, let's look at depreciation now. So remember, appreciation would have been gaining value, depreciation is losing value. And what is the big difference between appreciation and depreciation when it comes to the formula? It's a minus sign. So appreciation, remember, would have been P, open brackets, 1 plus R to the power of T. And depreciation is P, open brackets, 1 minus R to the power of T. Everything else means the same thing. So all we need to know is whether we're appreciating or depreciating in value. If we're going up in value, a plus sign. If we're going down in value, a minus sign. Let's look at an example. So it says a new network of computers costs $15,000. The value of this network depreciates at a rate of 20% per year. What is the value of the network after 2 years? Well, this is obviously a depreciation question when it comes to compound interest. So we have to know our depreciation formula. So that's A will be equal to P1. Depreciation is plus or minus? It's minus R to the power of T. Now let's see what values we have. The cost was $15,000, so this is our principal. The value of this network depreciates at a rate of 20% per year. What is the value of the network after 2 years? So let's go. We have found our values. A, principal is $15,000. 1 plus the rate. Now, is it 1 plus 20? No, it isn't. Remember, it will be as a fraction to the power of time. So that's 2. So that's 15,000. 1 plus 0.2 to the power of 2. That becomes 15,000. 1.2. Sorry, let me erase this because this looks like a 1. So let me just erase it to look properly. So that's a 2. Nice. So it becomes 1.2 squared. What is 12 times 12? 12 times 12 is 144. 2 decimal places. So that's 1.44. Boom. So then the total amount. Hold on. I was doing the wrong thing all the time. Come on, man. None of you all stopped me. You must stop that. Even if you feel like I'm doing the wrong thing, just tell me I'm doing the wrong thing, man. It's a minus sign because we're losing value. So then this becomes 0.8 squared. So then this becomes 0.64. Now what is 0.64 times 15,000? Me not know, but we can go in our working column and work it out. So, so that's 150 times 64. That's 9,000. That's 600. That's 9,600. So the amount that the system or the network is going to be worth after 2 years is now going to be worth $9,600. It lost a lot of its value. And how? Compound interest. Now, again, remember what we said, right? When it comes to losing value, compound interest loses at a slower rate than simple interest does. So in 2 years, simple interest, it would have been 20% times 15,000. That's 3,000. 3,000 times 2 is 6,000. So if it was simple interest, it would have been worth $9,000. However, because it's compound depreciation, it's worth $9,600. So if you're depreciating and losing value, it's better to lose value with compound interest than it is to lose it with simple interest. So let's continue. Look at this question. So the number of birds in the bird sanctuary is decreasing at a compound rate of 12% per year. If there are currently 3,200 birds at the sanctuary, what will the population be in 5 years? So same principle. It's not about money this time, it's about nature. But the formula works regardless. Yeah? So here we have our current amount. So this is like our principal. So our principal is 3,200. What is our rate? It's 12% per year. So 12% is 0.12 as a decimal. What would the population be in 5 years? So now we use our compound formula. A will be equal to P1 minus R to the T. So then that becomes 3,200, 1 minus 0.12 to the 5. That becomes 3,200, 0.88 to the power 5. And then this is where we will take out our handy-dandy calculators in our calculation. But I mean, if you know it, you can go ahead and work it out. But for us regular people like myself, we do 0.88 to the power of 5. So that's 0.527. So then we will do 3,200 times 0.527. And then when we multiply that together, we should get somewhere about 1,688, well, 89 birds, because you can't have a piece of a bird, right? So the population went down from 3,200 to a little over half of its value. And it's important on how we multiply this. Now, if it was simple interest, we know it would have been principal times rate times time. And when you multiply those together, you realize that it went down by 60% of its value. But when it's depreciation, compound interest, you actually go at a slower rate. Now, we're almost there. But there's one more formula I want us to look at. And this is generally considered a more advanced formula. So it's above fifth form, but it's just to understanding. And it may look more complicated now. But what is important to understand here is that the rate and the time must both be in the same compound period. The compound period determines the period. The compounding period determines the period. So if you are given an annual interest rate, but you are being compounded every month, then you need to change that annual interest rate into a monthly interest rate. If you are given years, if you're given 5 years, but you are compounding per month, then you must change the time from 5 years to 60 months. Everything must be within a compound period. So you can either change it for yourself, or you can use the formula, and the formula will change it for you. Let's look at the example. So what's the big difference here? The big difference is that we now have an N. And it's basically the number of times interest is applied per the time period. So if we have a question, so we were depositing $4,000 on the account, and it's 6% annual interest compounded quarterly. What is our time period that we must work in? Well, our rate is yearly, 6% a year. Let me make that look a little bit more legible. 6% a year. And we're compounding quarterly. How much money will be in the account after 5 years? Now, time is in years, the interest is in, the rate is in years. So do you think that our period should be years? You may think so, but remember, when it comes to compound interest, the compound period determines what our period should be. So we're going to do it both ways. We're going to do it one using the regular formula and then one using the special formula here. What special formula am I talking about? This particular one, where it will be 1 plus the rate over n and raised to the power of nt. But let's just write down the values as it is right now. So the principal we have is 4,000. The rate is 6% per year. The time is 5 years. But the compound period is quarterly. So, which means that since we're talking about years, the compound period is 4 times a year. Yeah? So, let's go. If we were to use the fancy formula, so the fancy formula is the amount is the principal times 1 plus the rate over n by nt, then let's just find the values before we actually put them in our formula, right? R over n, how much is that? That would be 6% over 4, which is 1.5%. But do we want it as a percentage? No, we don't. We want it as a decimal. So we divide it by 100 and we get 0.015. NT, that would be 5 by 4, which is 20. So now let's go. So that's A being equal to 4,000, 1 plus 0.015 to the 20. That's 4,000, 1.015 to the power of 20. Pull out our calculators and we work those numbers first. So then it becomes 1.015 to the power of 20. Again, if you're not too sure how to use your calculator properly, you'll work it using BODMAS. So 1.015 to the power of 20. We get the answer is 1.346855 going on. And then we will multiply that by our 4,000. And we get that our answer is $5,387.42. Now, let's conceptually go through the question based on what we know from before. Now, I'm on this side. Ooh, you've never seen me on this side, eh? It's such a difference. So, we know that the principal is the 4,000. Now, it's 6% annual interest compounding quarterly. So it means that we would have to actually find the interest rate per quarter. So the interest rate per year was 6% per year. How much would it be per quarter? Well, it would be 6 divided by 4, which is 1.5% per quarter. Yeah? So now we have our interest rate per quarter. What was our time given? Our time given was 5 years. Well, if there are 4 quarters in 1 year, how many quarters will there be in 5 years? Well, that means it will be 5 times 4, which is 20. Now, what are you seeing? Are you seeing that the rate here is the same rate we formed there using the formula? Are you seeing that the time here, are you seeing that the time here is the same time we formed using the formula? What is our regular formula for compound interest? It is that the amount is the principal, open brackets, 1 plus the rate by the time. So then this will be 4,000, 1 plus 1.5 over 100 times 20. And what you would realize is that this here and this here is the same thing. So even if you don't want to remember the new formula, you don't have to remember that. What you need to remember is that the rate and the time must be within the compounding period. If you're compounding per month, you have to change your rate to per month. You have to change your time to months. If you were compounding per year, you will have to change your rate per year, your time per year. If you were compounding per second, you will have to change your rate to second and your time to second. It is important to remember, regardless of how big and complicated the question may get, that compound interest, the compounding period, sets your period for your rate and it sets your period for your time. Now, when it comes to CXC for my fifth formers, I know some of us are watching, you expect me to be able to do that without a calculator? No. Difficult compounding questions do not come from multiple choice because you need a calculator to do difficult compounding questions. However, compounding comes with life experience. especially when you begin to deal with interest and banks and investing companies and going forward financially. So was this actually necessary or fully necessary for your CSEC exam in a month or so? No, not really. But I am not just here to teach you for July. Your life goes beyond CSEC. Your life goes beyond CXC. If the knowledge you are gaining is only going to be thrown away after, then the knowledge would have been wasted. You're wasting your time. Please, I am begging you, I am asking you, please, do not let the knowledge in math, English, science, whatever it is, just be for an examination. Your brain and your time, your effort, your energy is worth more than that. So, please, as you go forward in life, apply the knowledge that you would have learned now. You'll be amazed to see how it will come and apply further down in your life. So this has been today's session. Next class we will move on. We have to deal with currency and rates and electrical bills and stuff like that. And once you understand ratios and once you understand how to work with those, it will be a breeze. So don't worry about it. But tune in next time, and we'll go and finish up on consumer arithmetic before your examinations. Have a wonderful one. God bless.